Hey guys, Mr. Jenkins here with your last lesson of chapter 3. We're skipping 3. Well, no, we didn't. We covered 3.5 as an extra credit opportunity, but this is 3.6, which will be much more applicable to the test. So you'll have to have some sort of technology to kind of solve those 3 variable systems on the test, and that's kind of the main part of this lesson. But the learning target would be that we want to be able to use matrices and technology in order to solve systems of equations. Okay, we know how to solve 2 variable systems pretty easily by hand at this point, but we want to be able to solve those tougher systems. So we're going to look at matrices as an option and using technology. All right, so a little bit about matrices. I'm going to try to zoom in just a little bit to kind of see if I can fit all this on the screen. I know that makes it a little bit tougher to see on your end, but just for this first part, let's see. That's a little bit better. All right, so about matrices, some of the basics. Okay, this says the matrix at the right has how many elements? Elements are just all the numbers. So it has 1, 2, 3, 4, 5, 6 elements. All right, and so the size of a matrix, this is more important here. The size of a matrix is given by number of rows first and then number of columns second, right? So what's a column versus a row? This would be a row. This is row 1. So this is row 2. And then your columns run the other way, right? Think a column on a house or a porch. They are straight up and down. They are vertical. All right, so it has 2 rows and 3 columns. So we say its size is 2 by 3. The way you say that is 2 by 3. All right, naming the elements. So again, what you have to remember here, that's hard to see. I'll rewrite it. That just says find the element A. Sorry about that. Let it get caught up. A1, comma 3. All right, so A sub 1, comma 3. So that means row 1, column 3. Row 1, column 3. So row 1, column 3. That would be 3. You can actually use your calculator even to help you with that part as well. Next one says 2, comma 1, so that'd be 11. So that's just some of the basics. Another important thing, kind of going from systems into an augmented matrix, right? You can see that what we're doing, if we just look at the top equation compared to the top row, we're just taking the coefficient of each term and letting that be the element of the matrix. So 5x gets entered as 5, 2y as 2, z as 1, and then our constant kind of goes in that last column. All right, so when you're doing an augmented matrix, when you're using technology to solve, you are always going to have one more column than rows. All right, so I think that's pretty important to understand. So let me kind of just show one of these. Let's just do example 1 together. All right, so a matrix is always kind of just in brackets. I can tell that, our equation is, it's got 3 variables, so that means you need 3 equations. So I know I'm going to have 3 rows with 1, 2, 3, 4 elements apiece, so 4 columns. So this is going to be I can just look at this and tell it's going to be a 3 by 4. All right, so my top row is going to be 1 for 1x, -1 for -1y, and 1 for 1z, and then 6 on the other side. I think in the book they like you to put that little separator. I don't think that's really necessary. You don't see that on your calculator, so I'm not as worried about this part. Next one, we have 2, 2, 3, 2, 2. And then your last one, sorry about that. Your last one is going to be 3, 5, 4, 4. So nothing difficult really about transferring it from equations to matrix or matrices. Here's what you'll have to look out for. You can see number 2 on the filled out notes, but here's what you got to look out for. Okay, so let's say it's something like, I'm just going to make up a system here. Don't worry about solving it or anything, but let's say, well, let's just take this one and change a few things. So let's say it were x minus y plus z equals 6. And then the next one was, let's say 2x plus 2z equals 2. And then the last one, I'm going to eliminate one of those. Let's just say it was 5y plus 4z equals 4. So on one like this, you would have to think a little bit, okay? So you just have to, you have to, you know, once you enter this first equation, like as is, okay, you have established that this is my x column, this is my y column, this is my z column, right? So you have to use like 0 placeholders here, okay? So you would enter this one. I'll go pretty quick, not to take too much time. It's kind of like an extra example. You would have to enter this matrix as, and I do think there's something like this on the test, so pay attention here. So 1, -1, 1, 6, the same first row. Second row here would be 2, it's 2x. I don't have anything for y, so I would need a 0 here, and then 2 for z, 2 at the end, okay? And then my last one, I don't have anything for x, so it's 0x plus 5y plus 4z equals 4. All right, so again, just watch out for that if you are missing any you know, variables there. You have to use that 0 placeholder. All right, now we're going to get to the important part. Okay, so reduced row echelon form. So that's the key to kind of using matrices in order to solve an equation. Basically, your calculator can do this for you. It can take it from like what we did up there into this form. So if we read this, we know this means x plus 0y plus 0z equals 5. So altogether, that would mean x equals 5. Right? And the next one would mean y, or whatever your second variable is, equals -3. And then the last one, of course, z, or whatever your third variable is, equals 2. Okay? So that's kind of how you read that. So that'd be one way to write out your solutions. Or remember, you can do that ordered triplet. So we just go to alphabetical order, x, y, z. So that'd be 5, comma, -3, comma, 2. Just two different things that say the same thing, really. All right. So today I will show you how to do this in your graphing calculator. There's a nice step-by-step process outlined in the notes. But since this is a video, I'm going to skip through all that and just kind of give you, just kind of work out, you know, work one out. So this one's already worked out, but you know, I'll go ahead and show it quicker on the video. Okay. So the first thing I'd want to do to solve this 3-variable system would be to write it as a matrix. Okay. So that's step 1. Let it get caught up here. So my top row I can see is going to be 5, 2, 1, 5. My second row is 3, -3, -3, 9. My third row is 1, 2, 4, 6. You probably want to space it out a little more than I did just because my numbers are kind of jammed together here. All right, so have to enter that into the calculator now. Okay, notice on your calculator the word matrix is above the inverse of x button, or x to the -1. Okay, so everything we want to do is in there. First thing you want to do is enter your matrix. So you go to second, x -1, and that takes you into your matrix menu. So I'm going to enter this as matrix A. So I'm just going to hit enter, or sorry, no, I'm not. I'm not going to hit enter. I'm going to go over to edit. And I'm going to enter this as matrix A. So I'm going to hit enter now. So now, as is, it's a 1 by 1. So I need to change it to, remember, it's rows, so 3 by columns, so 4. So this is actually a 3 by 4. I'm going to enter 3, enter, 4, enter. Now I have it the way that I want it to be, okay? So now I'm just going to enter what I see here. So across, as you hit enter, it will go across the rows. I'm going to do 5, enter, 2, enter, 1, enter, 5. And when I hit enter again, it'll start me at the next row. So I'm just going to do the rest without talking through it. So just bear with me here. Obviously, you want to look up every so often and just double check. It's definitely easy to miskey something. All right, so we've got it in there, and there you see also, like I was saying earlier, if you wanted to name an element, say we wanted element 2, 3, then you could go down to element 2, 3, and it says it right there, 2, 3 is -3. Okay, I don't know how much you'll need that, but you can do that if you have trouble on those questions. All right, so once we have that in, now we want to get it into reduced row echelon form. So we have to go back to our main menu now. We have to get out of here. So to do that from anywhere is second and mode. That's quit. Takes me back there. Okay, now what I want to do is go to RREF. That's reduced row echelon form, kind of what we just talked about. So that's going to be under matrix. So second, x to the -1. And now this is going to be in math. And I'm going to arrow down until I get to RREF. It's option B. So you go past 9, past A, or sorry, past 0, past A, all the way to B, RREF. Now that's confusing because one's called REF, so be careful there. You want RREF. And I'm just going to hit enter. All right, now I have to tell it which matrix that I want to do RREF to. So this calculator only has one matrix entered, but I do need to put it, I need to tell it that it's matrix A that I'm talking about. So we go back into matrix, so second, x to the -1. And you can see, you can tell here now that I have entered a matrix for matrix A. So it's a 3 by 4. I'm going to hit enter to pull that up, and then enter again. And there you go. Then it's just a matter of being able to read what is in front of you, what that means, what the reduced row echelon form means, which we just talked about in the last example. Let's see how that looks. All right, so I'm just going to copy this for the notes. So we have 1, 0, 0, 2, 0, 1, 0, -4, 0, 0, 1, 3. All right, so that tells me then that my solutions are x is 2, y is -4, z is +3. All right, so I could leave it like that, or I could say 2, -4, +3. I don't really have a preference either way. Okay, let me see if I can find an example, another type of example. If not, I may cut it off there. All right, so actually number 4 is one that I would like to show, and then we'll probably cut it off, and then we'll go over word problems, probably as a separate video. All right, so let's go ahead and skip to 4. Obviously, you can see the other ones worked out in the notes. So first things first is write this as a matrix. Last problem, that was pretty easy. This problem, not as much. Okay, so we have top row 2, 4, -3, -3. Next row, pretty easy too. So 1, -2, -7, +5. And then here's where people will mess up. A lot of people would just do 3, 5, 3. Okay, so, or 3, 5, 3. All right, so that would not work. So you'd want, this is my X column, remember, so 3 goes here. This is my Y column, so 5 there. This is my Z column. So what would be my coefficient for Z? It'd be 0. Okay, so that's where your 0 goes. That's where your placeholder goes. And this is my constant column. So that's where the 3 goes. All right, once I have that, then we can go ahead and start to repeat that same process. I'll try to go just a little bit quicker here. So remember, everything's here in the matrix menu. Notice this is 3 by 4. I already have A set as a 3 by 4. So I'm just going to edit right over top of A. You can delete that, but I'm just going to, since it's already set up as a 3 by 4, just enter in our values right over top of what we have. So 2, 4, -3, -3. Next one, 1, -2, -7, 5. And then our last row, 3, 5, 0, 3. All right, so now we have our matrix entered. So now we need to back out. This is an important step. We need to back out. Actually, let's see what happens if I just hit second and matrix again. So I guess you don't need to back out. So I guess I misspoke earlier. So disregard that previous statement. Now we want to go to math and RREF. All right, so that's 12 down. RREF, and we want matrix A. So go back into your matrix menu. Matrix A, hit enter. And I did something wrong, of course. Let's see what I did wrong. Maybe you do have to back out. I bet you do have to back out. That's what the problem was. All right, so let's do second quit and try again. So you do have to back out. Sorry for the confusion there. So now we'll pull up RREF. And go ahead and enter matrix A. And now we're ready to hit enter. So now we know X is 6, Y is -3, and Z is 1. On my test, I would want to copy that matrix, but just to save a little bit of time, I'm just going to copy the answers. All right, so those should come up here in a second. Hopefully. But anyways, if it doesn't, you see what the answers are. X equals 6, y equals -3, z equals 1. The last point I would make is remember that you can always check these algebraically. If you're not sure if you've done something correctly, then, sub them back in, right? 6 goes there, -3 goes there, 1 goes there, okay? And it should work in all three. That's where I'm going to end this video today. I will go over the word problems as a video tomorrow where I will show you how this looks in Desmos. It's actually a little bit easier if you want to look into that on your own. So how do I solve matrices with Desmos, something like that. But I will go over that. I'll go over that tomorrow and the word problems. All right, if you want to try them on your own, that might not be a bad idea. Remember, the test is later this week, so make sure you're up on everything and make sure you're asking questions if you have any. Hope this helps. You guys have a nice